Hello class, I'm Harerimana Jamari, instructor in Geotechnical Laboratory at IPRC Kigali. The session for today will cover determination of workability of fresh concrete by Slump cone by BS 12350 part 2. This session will cover introduction or the aim of Slump test. Number 2, we will see the principles of Slump test. Number 3, we will see the apparatus to be used during this test. Number 4, we will perform all procedures concerning this test. Number 5, we will see types of Slump. And number 6, we will see the limitation and advantages of the test. Number 1, aim of Slump test. Slump test is the test to be done at site or at laboratory. The purpose of the test is just to determine the workability of the concrete when it indicates how much water to be used in the concrete to ensure the uniformity of batching similar concrete under field condition. Principles of Slump test. Slump test is a result of measurement of behavior of a compacted inverted cone of concrete under action of field. That's called workability. Here I can specify the real definition of workability. What does it mean? Workability, it is a property of a fresh concrete, the way it can behave when you are pressing, when you are mixing, when you are transporting, and so on. The workability is indicate the homogeneity of concrete when you are mixing without any kind of segregation or bleeding. Remember, a good concrete with a good workability, concrete has a good compressive strength. Apparatus. This is tamping rod. Tamping rod, it has the length of 16 centimeter and the diameter of 16 millimeter. This one we will be using for compaction. Number 2, we have a slump cone. A slump cone, it is where we will perform our test. We will fill the concrete inside so that we can perform the slump test. This cone, it has a flat stem shape with the upper diameter of 10 mm and 20 centimeter, and it has 30 centimeter of weight. Another one, we will be having a steel float just to smooth at the top of the cone. Then we will be having a steel ruler which will be used to determine the distance from the cone as reference to the slided concrete. Then we'll be having a thrower which we will be using just to put the concrete in the cone. Then we'll be having a cleaning, a sponge, just to clean our apparatus. So, number 4, we are going to see how the test is really performed, what we call the procedure of the test. And because this cone, it has both hollowed and we will be needing a base plate to put down so that the concrete, it will not flow down. So the first step is to see if our materials or our apparatus are well cleaned. So I'm going to clean my slump cone to be sure there is no moisture inside and there is no old concrete so that it can affect my test. Then I clean the base plate where I will put my cone. Then after, I will put my base plate on the ground where there is no vibration or any disturbance. After putting my base plate at the ground where there is no disturbance, just I will put my cone on the base plate so that I can start the test. For putting the concrete, I will need this tunnel. Then after that, I will take my tamping rod so that it can help me to compact the concrete. After that, I have to step on the concrete mold so that it cannot just move around so that it can disturb me when I'm performing the test. After that, we have to remix the concrete to be used. After the mixing, we will need this drawer so that we can put the concrete inside the slump cone. This cone will be filled in 3 layers. 3 layers for 25 strokes for each layer of the cone. That means 1 layer is 1/3 of the cone. Then we compacted the concrete by 25 strokes, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Then I need to put the second layer. The same procedure, I will compact 25 blocks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. I have 2 layers. Now, it is the last. It is the last layer. I will put the concrete so that the cone will be filled. 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So I have to top up so that the mold will just be completed. Put another one, small. No, it's enough. So after this, I have my cone filled with concrete. I will remove the surplus concrete so that I will remain with the concrete with the same volume with the cone. Then, give me that one. I will clean my working area so that I can proceed with other steps. You have to keep just the cone under your pressure. So I will touch here, then remove legs. And the first step is just removing the cone vertically. You see, now I removed the cone. Then after, I will reverse my cone. Then I put here, aside. Then I put my tamping rod here. Then, with using my ruler, I will measure the difference from the top of the cone and the maximum height of my concrete. Now I have 3 centimeters. Now we can say our concrete, it has 3 centimeters of slump. This is the value we was looking at. So next step, we will put the concrete where we can remix. Then we proceed with result and reporting. Our concrete, we have seen that the value for slump, it is 30 centimeters. Identification of the test sample. The sample was 001. And the location of the performance of the test, it is apparatus Kigali, lab. Then the date of today, it is 18th June 2020. The time, now we are at 11:20. Then we put the value of the slump we have seen. It is 3 centimeters, which equal to 30 millimeters. Then you have to declare that you are the one who performed the test. After that, we are going to see the limitation. This test is limited, of course. After limitation, we will see the advantage of this test. So, for limitation, this slump test should not be done if the aggregate as the component of concrete is greater than 40 mm of size. That means if you have a larger aggregate, you will not perform this kind of test. So number 2, in limitation, this test is not suitable for dry and very stiff concrete. When you have a very dry concrete and a very stiff, you will not perform this kind of test. Advantages of this test. As we said before, this test can be done at site or at the lab. Number 2, it requires less apparatus. As all of you have seen that the apparatus we used is lesser than other tests. Number 3, in the advantages, it doesn't take much time to evaluate the result. From starting at the end, the result, it can be get in a few minutes. Then, after that, we will see possible scenario you can have when you are performing a slump test. You can have a true slump. What does it mean if you say a true slump? A true slump is when you are moving your cone to the concrete, then the concrete just slides evenly. Just it comes down consistently at the same height as this. As you see here, this is the shape for the slump cone. This is in the blue color, it is for concrete. So if you remove your cone, your concrete just come down, slide a little bit, so that you can measure the difference from the top, the height of the cone, and the top level of the concrete. This is one type of concrete. Secondly, we have a collapse. A collapse slump, it will be causing with too much water. If you have a concrete with too much water and you remove your cone, all of them, it will slide at the ground in all directions. Number 3, we'll be having a shear slump, as this. One part, it goes down, and another one, it is just forming like a true slump. As you see here, one part of the concrete, it slides, and the other one remains just stand. So the difference in the height shows that the concrete, it has a shear slump. Then the last, when you have a zero slump. When you have a zero slump, it is when you have a very dry concrete, because when you remove the concrete cone, the concrete will remain the same as it was before. So this is the end of the session for today. Then I want to thank you, everyone who attended this session. Then thank you very much.